Welcome back as we continue on with Unit 6, Chapter 10. We're going to start the second section of Chapter 10. In this section, we're going to do part of this lesson in this lecture. The target for this lesson is I can find the number of combinations for various situations and problems. We talked about permutations yesterday. Today we're going to kind of see the difference between permutations and combinations. Have the target for your notes for tomorrow. So the only difference between combinations and permutations is that in combinations, order does not matter. Yesterday we talked about permutations. An example is a batting lineup for baseball because they matter what order you batted in. Also, we talked about stacking ice cream on a cone because that's an order you have to eat it in. Combinations, you can think about combinations as basketball starting squad. It doesn't matter whether you're announced first or last year, when the five combination of players on the floor, or ice cream, putting ice cream in a bowl. It doesn't matter what order you put them in a bowl because then you can eat them in any order you want. So combinations are situations where the order does not matter. The formula looks very similar. NCR equals n factorial over n minus r factorial times r factorial. So the only difference is adding this extra r factorial. So looking at this compared to our permutation model, is there going to be more permutations or less or more combinations if you're getting the same n and r? Well, you're actually going to have more permutations because if you have to order something, then there's more to take into account. If it's just combining objects and order doesn't matter, you're going to have a smaller number if you have the same n and r for both situations. You can see that we're going to have a bigger denominator because you have this extra r factorial at the bottom. The bigger number you divide by, the smaller overall result. So let's look at this one. Example 1. See the deck of cards on page 690. So if you flip to your book on page 690, or if you have a deck of cards at home, you can get it out, pause, get it out, take a look at all the cards face up. Okay. Using a standard deck of 52 cards, how many different 5-card hands are possible? If the order that the cards are dealt is not important. Well, you can count these all out, and we can see how many there are. But the big thing is we have 52 objects, and we're going to choose 5. Is it a permutation or a combination? Does order matter or not? And I would think the important part of this sentence is the order is not important. Okay? The order is not important, so that is a combination. 52 things, we're going to choose 5 of them. 52 factorial over 52 minus 5 factorial times the 5 factorial. And so if we did this by hand, I'm going to show you once how to do it by hand. 52 times 51 times 50 times 49 times 48 times 47 times 46, down to 1. On the bottom, it's going to be 47 factorial, right? So 47 times 46 times 45, down to 1, times 5 times 4 times 3 times 2 times 1. Well, why did I do that? Because you can see from 47 on down, we're going to cancel out. So all we're really left with is 52 times 51 times 50 times 49 times 48 over 5 times 4 times 3 times 2 times 1. So in our calculator, we can put all this in, and we can get 311,875,200 divided by 120, which comes out to 2,598,960 combinations of cards. It's just a 5-card hand. Okay? We can do this on our calculator as well. If you go to your calculator, hit 52, math, PRB. Well, this time, instead of NPR, we're going to choose NCR, or number 3. 52, choose 5, and we get the same number. Okay? So, do these on your calculator just like we did permutations. Parents have 10 books that they can read to their children this week. 5 of the books are nonfiction and 5 are fiction. if the order that the books read are not important, how many different sets of 4 books can they choose? So we don't care if they're fiction, I don't care if they're nonfiction, I want 4 of all the books. They have 10 total, so that's 10 things. We're going to choose 4. Let's practice that with our calculator. 10 things, choose 4, that's a 3. That's 210 items that we can pick. If you were going to set it up, it would be 10 factorial over 10 minus 4 factorial times 4 factorial. And I'll let you finish off the work for that as well. Okay, when you find the number of ways that both an event A and event B can occur, you need to multiply. When finding the number of ways that event A or event B can occur, you add. So and is multiplied, or is add. That's the big thing to take out of those statements. Example 1, William Shakespeare wrote 38 plays that can be divided into 3 genres. One of the 38 plays, 18 are comedies, 10 are histories, and 10 are tragedies. How many different sets of exactly 2 comedies and 1 tragedy can you read? Okay, so and is the key word here. And means multiply. So 2 comedies times 1 tragedy. That's really what we're doing. Well, we got to list out the possible ways we can get 2 comedies. Well, does it say what the order matters or order doesn't matter? It says a set. A set doesn't matter what order it's in. If it's in a set, they're all together, they're in a group. That's it. So the order doesn't matter. So how many comedies are there and how many can I pick from? Well, or am I going to pick? I have 18 comedies. I'm going to choose 2. Okay? Times tragedies. I have 10 tragedies and I'm going to choose 1. So I just go to my calculator, let it do the work. 18. We're going to choose 2. And then we're going to do, let's just do the other, oops, look at that. 10 things, not 100 things. 10 things. We're going to choose 1. And so I get 153 and I get 10. 153 times 10 is 1,530 choices. Okay? Sets of 2, I should say 2 comedies and 1 tragedy. Okay? So let's look at this. A different way to phrase something. How many different sets of at most 3 plays can you read? If you're doing at most 3 plays, I could read 3 plays, or I could read 2 plays, or I could read 1 play, or I could read 0 plays. Okay, so at most 3 is 0, 1, 2, or 3. So it's an or problem. It's really a hidden or problem. It's kind of a tough one, but you add them. So we're going to add 0 plus 1 plus the 2 plus the 3, and that's plays, okay? Not just 0 plus 1 plus 2, so let's put 1 play. So we have to be able to count how many ways we can read 0 plays, we can read 1 play, 2 plays, or 3 plays. Well, there's a total of 38 plays. So 38 plays, if we choose 0, that's 38 ways combined with 0, plus 38 plays, we're going to choose 1, plus 38 plays, we're going to choose 2, plus 38 plays, we're going to choose 3. So we go in our calculator and we can do the combinations for each of these. That's 1 plus 38 plus 703 plus 8,436. Well, you practice that in your calculator so you can get the same numbers I got there. And we add those all up. There's 9,178 ways to read at most 3 plays. So the phrasing on it, it's a little bit of English involved here. The phrasing on it is something you kind of got to read between the lines and see what they're really talking about. These word problems. Okay, let's do a few more just to make sure we have it, and then we're probably good. How many different committees of exactly 2 seniors and 2 juniors can be chosen from 6 seniors, 5 juniors, 4 sophomores, and 3 freshmen? So look for your keyword, your and or your or what's the implied and or implied or. And is explicitly written right here, and 2 juniors, okay, 2 seniors and 2 juniors, and means multiply. So we can pick 2 seniors, there's 6, 6 of them, choose 2, times juniors, there's 5, 5 juniors, choose 2. We put this in our calculator, we get 15 times 10, which is 150 choices. Down here, my timer here, how many different committees of at most 4 students can be chosen? At most 4. So at most 4 is a 0, or a 1, or a 2, or a 3, or 4. So this is like the problem we did with the Shakespeare plays. I have 18 people, choose none, plus 18 people, choose 1, plus 18, choose 2, plus 18, choose 3, plus 18, choose 4. And we put these in our calculator, or use the formula, however you want to do it. You should get these numbers. Plus 816 plus 3060. We add those all up, and we get 4,048 combinations. Okay, we did an implied or question. Let's look at an implied and, see if we can pick it up here. Use the standard deck of 52 playing cards, and how many 5-card hands are all 52 cards the same suit? Okay, all 52 cards the same suit. Well, if you're the same suit, there's 2 things that have to happen. You have to be the same color, and you have to be there's the same color and from the and same suits. Well, more importantly, there are four suits, and there are 13 cards in each suit. So if you're the same suit, you've got 2 things going on. You got you've one of 4 suits. So 4, choose 1. That's either a heart, you're a diamond, you're a spade, or your club. So there's one of 4 that you can choose from there. And you also have to be within 5 of the same 13 cards. Okay? So 5 out of 13. So you're choosing one of your suits. Okay? And then 5 cards from those 13 suits. So you're really choosing 3 things. You're choosing from one suit, and you're choosing 5 of the 13 cards in that suit. It's an and, so we multiply these. 4 choose 1 is 4. 13 choose 5 is 1,287. Multiply them together, we get 5,148. So it's kind of that's a kind of hard one to see possibly. So let's go through it one more time. If you're all the same suit, you're one of 4 suits: hearts, diamonds, clubs, spades. That's the 4C1. And once you choose a suit, you have to choose 5 cards out of the 13. So you have to do both things. So both things have to happen. That's an and that's a multiply. Okay, so that's an implied and problem. Okay, so that's day 1 of this lesson. We're going to find combinations. We kind of stepped up the game a little bit. We kind of looked at some and or problems as well. As we go through this, it's going to get more complex, and you're really going to have to look at the wording and how things are phrased to make sure you're doing an or problem. And you also have to look at combinations versus permutations. Does order matter or does it not? I'll have the notes ready for tomorrow. See you in class.